So if you've been with us for a while, you may remember that we've had a litany of problems with our charging, our means of charging. In the last crossing, we were gasping for power so badly, and the alternator and the AGM, the combo of those two, were just not up to the task of charging with the diesel engine. So instead of burning the diesel so early in the piece, which was a 3-week crossing, and turned out to be quite a drifter, we opted to use the petrol generator. So we had a petrol generator lashed to the mast for a couple of hours a day for many a day on a 3-week crossing. The guys at Electromaax were paying attention, and they actually saw this, sent me an email and say, hey, it seems like you got some charging issues on the Falcon. Are you interested in having a chat? We think we can sort it out for you. So what they've sent me is the following. The 215 amp large case alternator. Custom machined tensioner jockey thingy is a direct substitute for the parts on our engine, the Yanmar 4JH5E. The Emax Pro X charge controller. And this is a surge protector. So having lithiums now, some of you may or may not know, is that lithiums have a BMS, battery management system, and they actually have the ability to sort of say, we're done, no more, and basically turn themselves off, brick themselves for protection reasons, which if you're pouring hundreds of amps from your alternator into a battery that just switches off, that energy has to go somewhere. And if you don't have one of these or similar, you can cook your alternator. Because we've had so many failed alternators and charge controllers, we actually have a litany of controllers and alternators on board because we've had them repaired or bootstrapped or kind of got them working as a spare in the past. So we have the opportunity to do a bit of a side-by-side because we have so much crap on board right now. Side-by-side, straight away, you can see they're rather different units, obviously. But a few things jump out at me straight away. Firstly, this is a 215 amp alternator. This is a 100 amp alternator. The case is, I won't say substantially larger, but it is substantially different. You can see that the ventilation and the fan intake is wildly better. Wildly better. It's also not powder coated, it's anodized. This is powder coated, and if you see the one on the engine, that is our original Balmer, the powder coating is utterly trashed and it cracks. The other thing about powder coating is it keeps the heat in. It doesn't conduct heat very well. And if the heat comes from within, you've insulated the heat in. Even with a serpentine belt, it just got so hot that it could never put out even close to 100 amp. About the best we would ever get is maybe 80 for a very brief period of time, and then the charge acceptance rate of the batteries would knock that down, or the heat. I've seen, and the controller tells you how hot they run. I've seen this thing running at 120 degrees before, which is absurd. You can cook an egg on it. So I'm hoping that this one runs, because it's so much larger, it doesn't need to run at full capacity. And thus, and because of the anodized shell and the much larger ventilation, I'm hoping it runs a lot cooler and a lot more efficient, because the lithiums that this will have to contend with are going to accept as much as it can give them for as long as they need it. So also the charge controller, you can see there, they're vastly different. This is the Balmer MC614. This was our second Balmer controller, and it is allegedly the problem. When we thought that alternator had died, it actually turns out that this is what it was. It's useless. It's paperweight at the moment, which is not a good innings for a piece of equipment that costs this much. And a lot of the issues we had have been, I think, partly these spade terminals. They are a corrosion magnet, and they are often a source of problems for most equipment that employs spade terminals. These ones are quite clean, and so that isn't the reason that this one's failed, I suspect. I think it could be the ambient temperature in the engine bay, or who knows. I have no idea what's wrong with it. But frankly, I'm sick of trying to figure it out. These guys, however, opted to not do that. They're not exactly spade terminals, but they're sort of harness plugs. Idiot-proof in a way, because as you can see, it's color-coded, and each of the cables has a zip tie of the appropriate color. This also has something quite cool. So in here is a Wi-Fi hotspot, but the way you get into the interface for that is you dial in an IP address. You don't have to be on the internet. You connect to this Wi-Fi network, dial in an IP address, or click the link that you've created on your homepage on your phone, and it brings up a web-based control page, basically, so you can get all your state of charge, you can tune it up and down on the fly. One of the other things that affords you the ability to do is by connecting to a hotspot at that point. I'm told that the technicians at Electromaax can dial in and essentially tune your charge system for you. However, the downside of that, or it's not the downside, but it begs mentioning. I'm a fairly self-reliant kind of person, and I think you need to be to go cruising. So to be devil's advocate, None of that's going to help me in the middle of nowhere when I don't have a cell phone or internet. So, something to keep in mind. It's very cool and it's awesome, but I'd be doing a disservice if I didn't say none of that's worth anything if you don't have your phone. Lastly, as all good alternators should, this alternator, much like the Balmar, has an onboard dumb regulator. So should all of that fail in the aforementioned scenario, you can hook it up directly to your engine with internal regulation, so you don't need any of that, much like I've got my engine hooked up now. So there always is that fallback if we need it.
How's the installation?
Yeah, not too bad. You missed all the hard part. What's that?
I have no idea.
Yeah, it's gone okay. So one of the things that, like one of the downsides about redoing your engine system is you're possibly liable for some massive sort of O or 2 naught or 1 naught gauge wiring runs at significant lengths. Plus side for us is we had a system where the 2 battery banks that lived here, or the house bank and the starter bank, used to run to a switch and then to the alternator. So we had all this we had this redundant length of 2 naught wire. So I've just spent the morning cutting it out of these massive pipe conduits that I imagine are original, and sort of reclaiming all this wiring, which was fine, but the runs were excessive. Like I had to sort of rearrange it and reroute it. So I spent the morning doing that, and now I'm just putting in all of the battery center wires for the new alternator controller architecture. So it's coming together. Yeah, it's coming together quite simply. If it was like a drop-in solution or you were starting from near scratch, it'd be way easier. But because I had to sort of reclaim things and reroute things and figure out what 40-year-old wire goes to where under floorboards and things, it's a bit of a project. But it's going well.
Okay, I think you just need to repeat what you just said.
Remember the other day how I was saying that these things, the one that's on here is the first one we bought that's got to be 4 years old, and the powder coat is trashed. It's generally not good. Well, it's kind of given its last dying gasp, because as I've taken it off, the post, and I'm very sweaty, so it's not abnormal to get a little tingle here and there when your arm brushes against something. But I noted as I was undoing it, I was like, this is shorting into the body. Like, what's going on here? And just as I've got it out, I can see that what I think is the rectifier has like cracked. I can see clearly that the post has cracked out of the body. It's just not I don't know. It's not good enough. I'm not okay with that. Like, something this robust that has functioned, like if it was something I had done, I would have hooked it up and cooked it. I would have broken it, and that would be my fault in the diodes. But to be this run down and this badly corroded and failing and crumbling, like, that's just, I'm sorry, like that's not something I'm doing. And it's not like it's in a wet area. Like, we do have a wet bilge. Like, if I was to be the devil's advocate and be as hard as possible on myself, yeah, we have a wet bilge. It's a boat. Like, what do you want? It's not a climate controlled area. Like, it's a boat in the tropics, and this is an alternator for a marine engine. It needs to be able to stand up to this. Like, it sits right there. So we've just had a little internal discussion here about how much equipment has failed on us and where it's failed over the last 4 or 5 years now. This is the original Balmar that came with the boat when we bought it. And it first failed with a loose field wire, which sort of meant that it was like our first Atlantic crossing, and the batteries were putting like 17, 18 volts. Sorry, the alternator was putting 17, 18 volts into the batteries, and we were like, oh, what do we do? And then I rigged it up to run on the internal controller, which is fine. The guys here at Electech sort of jury-rigged it to work, but I've never trusted it since to run it with an external regulator. So right, first failure, first alternator. Then we replaced this alternator, not really trusting it and wanting to use an external regulator, and we got it in a kit. So then we got a different Balmar controller, a slightly better one, the MC614, and the same alternator. And on the last trip again, the controller failed, and we don't know why. So in 4 years, we've cooked one alternator, or we've had a field wire problem on one alternator, and we've cooked a controller. And we've, in total, purchased 2 alternators and 2 controllers. and none of them have survived as a pair, as a combo. So I'm just, yeah, somebody else is going to get a turn, I think. I'm very happy to be giving someone else their moment in the sun. So, as you can see here, I've set up a little home office in the hallway. Got my laptop, got my electrical tools, and we've got the charge controller. So what I'm doing here is I'm just going through the configuration portion of the install. So they give you a thumb drive with the manual and a little, I guess you could say a Windows executable. And then you get a USB to USB, you get a connection cable that allows you to plug in to the controller and do all of the configuration and just check all of the settings. It's not fiddly, it's not even complicated, but one of the more detailed things you have to tune in is because this controller has 2 shunts that you install, and it's got a decent wiring run where it measures current and there's resistivity in those wires, you need to tune out the resistivity in the wires for the current measurement. So you sort of want the system in a completely resting state, no current running through anything, and then you sort of take these 2 little screws on the controller board and you just tune it down to 0, and then while you've got the controller plugged into the computer, when you open the executable, you can see a live reading of all of the parameters that the controller is reading. So between those 2 things, you can tune them down to 0, and you can make sure that the resistivity in the wiring is compensated for. So one of the cool things about this this controller is that it's also a wireless hotspot, so you can connect to it with your phone or your computer. So let's go through that now. So you turn on your Wi-Fi, it looks for a network, it finds something called X regulator, which then connects to. So then you go into your browser and you type in 192.168.0.1, search go, and you land on this page, which gives you the gauges view, so the voltage at the bank, the current draw across the shunts, the temperature, the load current, the alternator temperature, the alternator's amperage going out, the field wire percentage or the field percentage, which if you don't know is sort of how much throttle the alternator is putting in. Like if you're at 100%, then you're flat out. If you're at 1%, then you're really not even trying. And your engine RPM. So you can get all that in your pocket from your phone upstairs. Then you can go across to tables view, which gives you sort of a more tabulated version of the same data, and then settings, where you can go and settings. Then you can change, you can the aforementioned shunt resistor levels. You can turn the Wi-Fi on and off. You can put a password on your Wi-Fi. You can change the SSID name. You can turn on or off the NMEA functionality. You basically just a full array of settings you can adjust from right here.
Adam has done the honours of installing absolutely everything, and now we think that we're at the testing stage, where that just involves pretty much turning the engine on and seeing whether the alternator starts putting some power in. So, you think it's time?
I think it's time.
Alright, let's do this.
Dead idle. Just going to let it sit happily at idle.
Okay, well, the engine's on. Yep, it's working. You said give it 10 seconds.
Yeah, it takes like a 10-second boot up.
Alright, because right now we're currently drawing 9 amps,
That's
17
okay, that's
amps.
the boot up.
So, just waiting. Okay.
It's running smooth, alternator's running smooth.
Right,
here we go. 52 amps at idle, so that's
there we
good.
go. This alternator current is starting to now increase.
I'll put some revs on too and see if it picks up.
Alright, so Adam's just put some more revs on the engine. So that's just the alternator and that's everything with solar, right?
Yeah.
Okay.
It was about now that we started seeing some confusing values from the readout. For example, how does a 215 amp alternator create 260 amps? And with no load on the batteries, no solar, and no wind, how are we drawing 68 amps from the battery? After another day of troubleshooting, I did manage to get it figured out.
So after 2 days of tedious troubleshooting, I've been pulling my hair out of my head, trying to figure out why the Victron BMW results didn't match the charge controller display. So the charge controller gives you alternator output current, battery voltage, battery current, and the load, and temperature and RPM and some other things. And those numbers didn't, rather the battery current didn't at all correspond to the Victron's value, which sort of was okay, but they were a lot out. They were consistently 20 amps out. So that kind of was a bit, something's not right. And then I started seeing amperage coming out of the alternator side that was higher than the rated value of the alternator. A 215 amp alternator should not be putting out 260 amps. So that led me to believe that both of the shunts were not calibrated correctly. So after pulling out my hair, trying to get in touch with support, which I got one email back asking for more questions at this time yesterday. I've followed up since then. I've got nothing, so basically you're on your own. But I discovered that by messing with the alternator and the battery shunt resistance values, I could control the readouts for the current, because that's how they work. They measure a voltage drop across a resistor, and with those values, using Ohm's law, you can figure out how much current is passing through there. So what I ended up doing was just essentially a series of guess and check tests to optimize the shunt voltages. I now have a pretty good understanding of, I think, of the system and how I can control the figures and what which lever to pull to make things happen. And the one saving grace across all of this was that the voltages have always been on the money. The currents, yeah, they're a bit screwy, and I've got them dialed in now, but the voltages have always been bang on. And as far as I can tell, as long as the voltages are protected, or rather consistent and operating correctly, consistent with the multimeter, then I can't hurt anything. Not hard, but far from simple. The manual's not bad, but it's not good, and support is a token gesture, but they've basically been AWOL, which is sort of a disappointing end to an otherwise pretty cool experience. In summary, it was a rough process, but now we have 215 amps potentially going in to the battery bank at any one time. That's absurdly large amounts of charging. I just ran it for 20 minutes just to sort of confirm my results that I just explained, and I saw 180 something amps going in the whole time, and the battery temperature was a consistent 90 something degrees, which when it's working flat out is pretty good, as in the controller didn't throttle it back. So quite happy with that. I'm happy to put the project to bed, and I'm happy that we can now charge many days worth of energy in an hour. I'm going to put a pin in that one and call it done. I will keep my eyes on it, and you'll be the first to hear about it if it misbehaves or gives me any more problems.